Floods. Events of such violence, they turn oceans, rivers and lakes into devastating walls of water. On average, around the world, these powerful surges kill 25,000 people every year. In 2016, a storm surge following Hurricane Matthew inundated the southern US coast, washing away roads and killing 52 people. Only a few months earlier, flash floods in Maryland and West Virginia killed 28 people and left 40,000 without power. 2004, leaving over 200,000 dead and $10 billion worth of... But could Mother Nature have unleashed floods that were even bigger and more destructive in the past? That's what a series of discoveries is suggesting. Scientists are unearthing what look like the scars of cataclysmic floods that dug deep into the rock, reshaping the surface of the Earth itself.
They completely changed the face of the landscape.
No one has ever witnessed anything even close in scale.
Across the world, 3 far-flung locations share an eerie similarity. In the United States, over 40,000 square kilometers of dry canyons and bizarre rock formations. In Iceland, a 90-meter deep gorge appears to have been ripped out in an instant. And off the coast of Britain, a network of mysterious canyons carved deep into the seabed could reveal how this channel first separated what is now Britain from France. Far from eroding gradually, there's evidence that vast deluges tore out these landscapes in the geological blink of an eye. But what could have triggered such killer floods? And could one strike again? The trail of clues starts here, in Northwest America. The plains of Washington State stretch for hundreds of kilometers, until suddenly, the landscape changes. Flat fields give way to sheer gorges, some almost 300 meters deep. Rock islands rise to the height of 30-story buildings, while in other places, strange round depressions, like gargantuan potholes, plunge 15 meters. These are the scablands, named by settlers who thought the features resembled scabs or wounds on the rocky terrain. Located over 100 kilometers east of Seattle, this mysterious landscape covers an area of around 40,000 square kilometers. For over a century, geologists have been trying to understand what forces created the scablands.
When you encounter a landscape, it's not unlike a detective encountering a crime scene. In the case of this landscape, there are features that act like clues.
But spotting those clues takes a trained eye.
You can't really get a sense of this area unless you get up high. This part of the scablands is like 30, 40 miles across. It's on a mega scale.
It's the kind of scale that first led geologists to suspect that the scablands had formed slowly, eroded over millions of years by rivers, wind, or ice. During past ice ages, as temperatures plummeted, giant ice sheets and glaciers carved deep valleys through solid rock. Like these, in Glacier National Park in Montana. And rivers scouring rock over eons helped carve some of the most dramatic landscapes on Earth, like the Grand Canyon in Colorado. But mapping sediments left behind by the ice sheet when it melted 12,000 years ago shows the ice only made it to the northern edge of the Scablands. And Vic Baker's bird's eye view reveals that fast-flowing water was the culprit. The clue? This curved canyon.
Looking at this from the air, you can see that the shape is like a horseshoe, which is what forms in waterfalls.
Niagara Falls and many big waterfalls have a similar horseshoe shape. For that reason, this canyon is called the Dry Falls. But stretching 5.5 kilometers, this formation is 5 times the span of Niagara and twice as tall.
The cliffs behind me are 400 feet high. Niagara Falls would fit just within the alcove here. There's a similar size alcove, and there's an even bigger one that extends many miles to the east.
These are the most extensive known falls, wet or dry, on Earth today. And in a valley below, Baker finds another clue that vast amounts of water once flowed here. Features that look like sinkholes or potholes, often found along the bottom of turbulent rivers. But these potholes are super-sized.
You can see it's maybe 50 feet deep or so. Potholes you see in a normal river are about the size of a person, whereas this would hold multiple elephants.
The evidence points to flowing water on a massive scale. But there's no water flowing here now. Today, the largest rivers in the region are the Snake and the Columbia. But Baker doubts that either of them ever played a role.
The Columbia River lies about 30 miles to the north and isn't big enough to make this kind of feature.
The Snake River as well is simply too small to carve out potholes and waterfalls on this scale.
To get such an immense volume of water so fast, we need something spectacular to happen.
So where did the water come from? Scientists are finding fresh clues to what created the channeled Scablands in Northwest America, 5,500 kilometers away in Iceland. This island on the edge of the Arctic Circle is a land of fire and ice. In its northeast corner are scars on the landscape that bear a striking resemblance to the Washington Scablands. A horseshoe-shaped gorge, sheer cliffs over 90 meters high, and a towering rock island. This is the Ausbirgi Canyon. And like scientists in the Scablands, geomorphologist Michaela Tal wants to understand how it was created.
This really looks like a dry waterfall. It's as if there was a big waterfall here, and it's not there anymore.
This horseshoe-shaped canyon is so similar to dry falls in the Scablands that Atal suspects they were both formed in the same way. And in the rocks, he's finding clues to how long it took. Using a relatively new technique called surface exposure dating. Earth's surface is constantly bombarded by cosmic rays from outer space. Rocks buried in the Earth are sheltered from these rays. But as soon as the rocks are exposed, like in these cliffs, cosmic rays collide with atoms at the surface. The force of these collisions knocks neutrons and protons out of the atoms and changes the elements in the rocks. This leads to the formation of new elements, including a rare form of helium. These rare helium atoms build up over time at a predictable rate. So by measuring their concentration, it's possible to determine how long the rock has been exposed.
And it's like starting the stopwatch.
Atal samples rocks from all over the Auspiergi Canyon and compares the dates when they were exposed. His results reveal something surprising. All the rocks in this area were exposed at the same time, meaning that this entire canyon was carved out all at once.
This canyon was created in one event, 9,000 years ago.
A slow-moving force, like a glacier, erosion or gradual uplift, would have exposed the rocks along the canyon at different times. So it had to be a fast-paced, natural disaster, like a titanic flood.
It would have been a flood on a scale far greater than anything that we have witnessed in human history.
Thousands of kilometers away, scientists in the Scablands had zeroed in on the same idea.
Everything in this landscape was screaming, in terms of its signs or clues, that this was made by catastrophic flooding.
A flood big enough to carve these vast landscapes seems impossible. The most destructive floods, from Hurricane Katrina in 2005 to the Japanese tsunami of 2011, have etched painful memories. But they have done little to make a mark on the underlying bedrock, like we see here in Iceland and in the Scablands.
No one has ever witnessed anything even close in scale.
We're talking about floods here that completely changed the face of the planet.
Floods powerful enough to carve whole canyons out of bedrock are rarely seen. But in 2002, one was finally caught on camera. On July the 4th, after a severe storm struck central Texas, Canyon Lake Reservoir flooded, overtopping its dam. At its peak, enough water to fill an Olympic swimming pool poured over every 2 seconds. And when the floodwaters subsided, they revealed a brand new gorge carved into the rock, 7 meters deep and more than 2 kilometers long. This provided proof that floods can transform whole landscapes in a matter of days, as long as there's enough water flowing with enough speed. And in Iceland, geophysicist Magnus Gudmundsson thinks he has figured out how such a massive release of water could occur. He's come 160 kilometers south of Auspiergi to the Vatnajökull ice cap, the largest glacier in Europe. similar to glaciers at the end of the last ice age, 9,000 years ago.
This glacier is the only possible source of water to create these floods that made Rovsbergi.
In places, it's over 900 meters deep. Hundreds of cubic kilometers of water locked up as ice.
We have all this ice here, but how does it become a flood?
Gudmundsson believes the secret lies in what's hidden beneath the ice cap. 7 huge volcanoes. In 1996, one of these, the volcano called Grímsvötn, erupted, triggering the most catastrophic flood in Iceland for more than half a century.
From time to time, we have these very large eruptions that melt enormous amounts of ice in a matter of hours.
Over 3 cubic kilometers of meltwater from the eruption tore across the landscape at 16 times the rate of Niagara Falls, destroying roads, bridges, and power lines. So today, Gudmundsson is monitoring the volcano. By recording elevation and movement, his team has discovered there is still a lake of meltwater beneath the ice.
We are actually standing on an ice shelf, floating on the lake.
Gudmundsson now believes that 9,000 years ago, a giant eruption under the ice cap unleashed a colossal flood, powerful enough to carve out the Ásbyrgi Canyon. So could a chain of events like this have also triggered a flood, massive enough to carve the scablands in North America? "160 kilometers west of the scablands are many active volcanoes. Notably, Mount St. Helens, partially covered in ice. In 1980, Mount St. Helens erupted, releasing an enormous amount of heat. Enough to melt the ice around its crater and trigger dramatic floods. But even if all the ice on this volcano had suddenly melted, it wouldn't be enough to carve out rock over a 40,000 square kilometer area. But what about in the past? To find out if ancient ice were to blame, Vic Baker needs to find out when the landscape was created. Taking samples from all over the scablands, he discovers most of the rocks were exposed within a few thousand years of each other. In geological terms, that's the blink of an eye. And one date in particular stands out.
Many of the dates we get are in the range of about 16,000 years ago.
Although ice sheets covered much of North America 16,000 years ago, geologists believe the ice stopped short of the volcanoes of Washington state. The trail of clues seemed to dry up. Until a surprising discovery changed everything. More than 300 kilometers east of the channeled scablands in Missoula, Montana, geologist Larry Smith is heading up into the hills, hunting for evidence of where the giant floodwaters came from. From up here, it's possible to see a series of horizontal lines, 300 meters above the valley floor.
They look very much like they'd have been cut into the hillside by waves beating against the rock. These lines are clearly lake shore lines. and show that an immense body of water temporarily filled these now dry valleys of western Montana.
Tracing these ancient shorelines for hundreds of kilometers, geologists have calculated that these valleys were once filled by a body of water larger than Lake Ontario.
When there was a lake here at 4,200 feet, we would have had a beach right here in front of us, or a shoreline, and extending all the way across to the other side of the valley with 1,000 feet of water over what is now the city of Missoula.
Geologists call it Glacial Lake Missoula.
That is a vast amount of water, and if this lake drained very rapidly, it would be fundamental to carving the channel scabland.
But today, there is no lake here because the valley is open-ended.
So the question is where, when, and how did a dam form to create this lake?
Smith travels back down to the narrow end of the valley. There are no signs here of landslides or rockfalls that could have dammed the lake in the past. But on the bare rocks, he spots some telltale markings.
You see scratches within the rock. Geologically, it is impossible to smooth off rock and scratch it without glacial ice.
As a glacier moves, rocks embedded within it scratch the bedrock like sandpaper. So these scratches are evidence that during the last ice age, a glacier moved across this valley. And by mapping where rocks have been scratched, geologists have discovered that the Clark Fork River Valley was once blocked by a giant finger of ice, 37 kilometers wide and 800 meters deep. Larry Smith believes this ice dam created Lake Missoula.
It blocked the drainage of the Clark Fork River. The water had nowhere else to go, so backed up a lake behind this large glacier in this valley.
All the evidence points to a massive reservoir of water held in place by a giant dam of ice. A lake large enough to have carved out the canyons of the Scablands if it were released in one catastrophic event. The idea that there had once been a lake here, suddenly drained, also explains one of the other striking features on the valley floor. Giant ripples.
These straight-crested hills are current ripples that show water flowing from where we're standing off to the distance.
Ripples like this are made by flowing water, like the tide moving in and out on a beach. The faster the flow of water, the larger and more widely spaced the ripples become.
Here, they're giant things that are spaced hundreds of feet apart, and they're tens of feet high.
These ripples are so high, the lake water that created them must have poured through this valley at speeds of nearly 130 kilometers an hour. It's evidence that Lake Missoula was unleashed rapidly in a massive flood. But that means the 37-kilometer wide ice dam holding it in place must have suddenly given way. How could an ice dam of this scale fail so catastrophically? The exposure dates of the rocks in the Scablands reveal the flood occurred well before the end of the Ice Age. This rules out gradual melting from a warming climate. But looking at modern dam failures could hold a clue.
People downstream better get out.
In 1976, the newly constructed 90-meter-high Teton Dam in Idaho failed, unleashing almost 300 billion liters of water. The flood carried away houses and cars and killed 11 people. Investigators discovered that water had seeped under the earth-filled dam, eroding it from below. Larry Smith believes water seeping under the ice dam also caused the catastrophic release of Lake Missoula.
At the bottom of this 2,000-foot deep lake, the water pressures are immense, and any small cracks in the ice will get penetrated by that high-pressure water. In doing so, that'll expand that crack network to form tunnels under the ice.
Lake water began draining through these tunnels at a faster and faster rate, until the whole ice dam suddenly collapsed.
It falls within minutes to hours with a cascade of water coming through the area.
Most people think of floods by watching the TV, and they see the water rising in a river, and they see a house going underwater. Maybe there's a person on top of the house. Think of water hundreds of feet above the house. That's the difference in the scale of this flooding.
Bringing all the evidence together, scientists can now unpack the catastrophic flood blow by blow. Around 16,000 years ago, the vast ice dam holding back Lake Missoula failed, suddenly unleashing 2,500 cubic kilometers of water.
It was equivalent in volume to 10 times all the rivers of the world's natural flow.
The raging torrent tore across Washington state, ripping out billions of tons of rock from the once flat landscape.
There would be blocks of ice, there would be boulders, there would be roiling water. The sound would be overwhelming.
In a matter of hours, the flood reached the Pacific Ocean, carrying with it 5,000 cubic kilometers of rock and earth violently torn from the scablands.
To do all this landscape change within a few days to a few weeks is just mind-expanding.
Even Hollywood disaster movies do not compare to what would have happened as this flood came across the landscape.
Decades of geological detective work show that the scarred and eroded landscapes of Northwest America, as well as Iceland, both bear the fingerprints of megafloods. And now, this discovery is helping scientists unravel a mystery in another part of the world. Thousands of kilometers away, in the channel that separates Britain from France. Today, the English Channel links the North Sea in the east to the Atlantic Ocean in the west. It's the busiest shipping lane in the world. And towering more than 100 meters above it, on the south coast of England, are the White Cliffs of Dover. Geologists like James Lawrence now think these iconic chalk cliffs hold an extraordinary secret. And he's going over the edge to hunt for the evidence. Because these cliffs look almost identical to the cliffs on the other side of the channel, on the northern coast of France.
People don't realise that if I was to go over to France, we could find similar chalk cliffs.
This chalk formed 100 million years ago, when this whole area was covered by a tropical sea. The ancient sea teemed with microscopic organisms. When they died, their calcium-rich skeletons fell to the seabed. Over time, these built up in thick layers and were compressed into chalk, a kind of limestone.
We are getting exactly the same rocks which have been deposited in exactly the same environment on this side of the channel and on the French side of the channel.
And Lawrence has discovered clues that the connection between the cliffs in France and England goes beyond the chalk itself. Embedded in the white chalk are a series of horizontal bands of a dark rock called flint.
Here I have a fantastic band of flint.
A form of the mineral quartz, flint is formed by changes in ocean chemistry. But these changes occur only occasionally, resulting in these distinctive dark bands.
These flint bands are continuous throughout the chalk.
This band of flint runs through the entire cliff. And there are dozens running horizontally. Each one at a different depth in the chalk. Taken together, these parallel bands of dark flint form a unique geological fingerprint in the white cliff. What's intriguing is that the same geological fingerprint is visible on the other side of the channel.
So the chalk and the flint in these cliffs forms a barcode and is exactly the same as the chalk and the flint in the cliffs in France.
The spacing and depths of the flint layers perfectly align. To Lawrence, this was conclusive evidence.
So what we know from this evidence is that a chalk ridge once connected England and France.
These flint layers tell us that hundreds of thousands of years ago, a ridge of chalk over 11 kilometers wide once extended 34 kilometers across the channel, joining what is now Britain to the European continent.
So it's quite incredible to think that there would have been a landmass stretching across the sea.
But this discovery led to a brand new mystery.
Somehow the cliffs between England and France have been separated over time.
If Britain and France were once joined, what force separated them and turned Britain into an island?
Full control, Maverick.
While exploring the seabed of the English Channel, geologist Jenny Collier found a clue that could reveal what happened to the ridge of chalk that once connected Britain to France.
4, 5, 6, 10 meters in a split second. We've got a really steep drop-off in the topography, and it's the edge of a really unusual landform.
Using sonar to measure the depth of the channel, Collier was surprised to find what appears to be a steep canyon carved into solid bedrock. Sonar works by firing sound waves at the seabed. The deeper the water, the longer it takes the sound to make the round trip. Collier expected the channel floor to be flat, but the sonar has revealed something far more dramatic.
We've discovered just an extraordinary geological event right in the middle of the Straits.
Despite the global importance of this shipping lane, little was known about the sea floor beneath the channel. So to investigate the major geological find, Collier and her colleagues took on a massive task. Using a more advanced sonar system, they mapped 136 square kilometers of the channel to an accuracy of 10 centimeters. And what this revealed was a strange picture of channels, rock islands, plunge pools and valleys, carved nearly 90 meters down into the rock of the seabed.
I mean, we haven't got anything like this in Europe. There's really only one place that has all of these features.
Without the water, the terrain beneath the English Channel looks eerily similar to the channeled scablands of Washington State. This underwater landscape looks like it was also created by a mega flood.
The only way you can dig out islands into solid bedrock is to have extreme water flows, and that basically pointed us towards this was yet another catastrophic flood terrain.
What the scablands revealed is that carving these kinds of features into solid rock requires a huge reservoir of water to be trapped, then released in a single cataclysmic event. But today, the English Channel flows between two open seas. It seemed impossible that a large enough volume of water could ever have built up. But geologist Phil Gibbard believes he has an answer. And the evidence lies 200 kilometers north of the English Channel on the North Norfolk coast, at the bottom of these cliffs.
What we've got here is a glacial deposit, which is from about 450,000 years ago.
Deep, fine-grained deposits like this were laid down across northern Europe as giant ice sheets ground over rocks. 450,000 years ago, Britain was in the grip of an ice age. Sea levels were lower, ice sheets hundreds of kilometers across and 1.5 kilometers high reached down from Scandinavia. They would have dammed the northern edge of the North Sea basin. And to the south, the intact ridge of chalk between what is now France and England formed a natural dam. Phil Gibbard believes that meltwater from the ice sheets and rivers pouring into the North Sea basin had nowhere to go, and water built up behind the chalk ridge in a vast lake. He sees the evidence for this Ice Age reservoir in the sea cliffs as thin, horizontal layers of silt.
The sediments are horizontal, as you see. That horizontality can only be produced in a lake situation, a standing water situation.
And not in a turbulent area like an ocean. Gibbard has discovered similar-looking formations in other places around the North Sea, some 30 meters above sea level today.
So this was a massive lake on the scale of the Great Lakes in North America, and this lake provides the only possible source for the mega flood that formed the Dover Straits.
The evidence suggests that this vast glacial lake drained to form the dramatic features on the bed of the English Channel. And it had to happen fast.
In order to carve these features, this rock ridge must have failed very, very rapidly.
But scientists wondered what caused this. How could the giant bridge of solid rock between France and Britain have given way so catastrophically? A clue could lie in the way chalk reacts to water.
Having a glacial lake in contact with a chalk ridge would have saturated the chalk, making it much weaker and much more likely to fail.
When water soaks into chalk and saturates it, the chalk can lose half its strength, making it far more likely to fail.
One of the problems with the chalk being so weak is that it will often lead to cliff collapses like the one we can see behind us.
Every year, thousands of tons of rain and wave-soaked chalk collapse into the channel, dramatically eroding the coastline. Many geologists now believe that during a previous ice age, almost 500,000 years ago, water from the North Sea reservoir soaked the chalk ridge, fatally weakening it. Once the lake was deep enough, water began pouring over the top of the ridge in a waterfall, rapidly eroding the waterlogged chalk.
We'd have had initially a small stream of water coming over the top of the rock ridge. It would have catastrophically crumbled with the large amounts of rock being removed and more water flooding through.
From the shape of the features on the sonar, Jenny now estimates that the floodwaters raced through at a rate of 1 billion litres a second. That's nearly 6 times the flow rate of the Amazon River.
You would have seen a tidal wave overtopping and washing a giant gorge into that landscape.
The deluge crashed on, breaking through the chalk ridge that once linked Britain and France, before finally reaching the Atlantic Ocean. It was this cataclysmic flood that created the English Channel and began the process of erosion that led to what's now Britain becoming an island for the first time. The clues in Iceland, the English Channel, and the channeled scablands of Washington State reveal that floods bigger and more devastating than anything we see today have torn across and helped shape the Earth's surface.
These giant mega floods totally shape a landscape in a matter of days or weeks.
But the question is, could a flood on this scale happen again? The one thing all these megafloods have in common is that they involve huge volumes of ice melting and being released in one sudden burst. In Iceland, a volcano beneath the ice sheet could trigger a megaflood at any moment. Fortunately, very few people live in the Icelandic flood zone. And the huge volume of ice needed to create glacial lakes on the scale of the ones that carve the English Channel and the scablands can only build up during ice ages. But there is one region on Earth today where stores of melting ice still pose a major flood risk to millions. Ice and snow-covered mountains.
Wherever you have glaciers, you have a lot of water. Wherever you have glaciers in a mountain, you have the high likelihood of making a glacially dammed lake. And those glacially dammed lakes are unstable and could drain catastrophically.
We're not going to get today releases of water like Lake Missoula that was 2,000 feet deep. But we can get glacial lakes that are 100 feet deep. And these will produce really dangerous and spectacular floods.
Today, floods, although smaller than in the past, continue to devastate lives and livelihoods. But the vast killer floods of the past transformed the surface of our planet and changed the face of continents. Their scars are a stark reminder of the destructive power of catastrophic floods.